Welcome, we're a group of seniors from UW-Madison and we're in Biomedical Engineering Design.
I'm Lauren.
I'm Johanna.
I'm Madison.
I'm Claire.
I'm Lewis.
And today we're going to talk to you about
Bioinstrumentation! And walk you through a fun LED circuit.
Before we get into our fun project, we first want to share some information about the Biomedical Engineering Department at UW-Madison. The BME program helps its students learn the essentials of biology and engineering to make innovative discoveries in both science and technology. One of the main components of biomedical engineering is bioinstrumentation. Bioinstrumentation is the application of electronics, measurement principles, and techniques to develop devices used in diagnosis and treatment of disease. A common career following this education is the development and testing of medical devices. One example is the electronic pacemaker seen in the upper left corner. The study of bioinstrumentation has made it possible to both invent and improve the pacemaker to be fully implantable in the human body and help over 3 million people worldwide live with improved heart function and extend their lives. Other examples include a brain-computer interface, implantable electrodes, sensors, tumor ablation, and other medical devices. The BME program at UW-Madison also offers students a unique opportunity to try their hand in product innovation and development. For example, our team has been working for the past 18 months on a digital pressure sensing mat that will be incorporated into a yoga mat. This device will be used by physical therapists to help assess a patient's ability to complete certain exercises and evaluate their posture. To create this device, our team used our knowledge of circuits, computer programming, and engineering to create the initial prototype shown in this video. Now it's time for you all to learn a bit more about circuits and build your own.
And this is Wisconsin LED art. Electricity is when a particle, called an electron, moves from one place to another. In doing this, it moves the energy that it has with it. We can see this with lightning. It is a short blast of electrical current as the electron brings energy from the clouds to the ground. We can use this movement of energy in our batteries and outlets. These power things such as our flashlight and fridges. Every time you plug in a phone, you can thank electricity for charging it. In order to control where electricity can flow, we can use conductors. Conductors are materials that allow electricity and its electrons to flow. The opposite of this is an insulator. Insulators do not allow electricity to flow. Metal is a good conductor since it has ions within it that can help electrons flow. So now time for some definitions. Current is the flow of electrons from one place to another, like in the lightning example from before, where these electrons are being moved from the clouds to the ground. Volts is what makes the current move. Resistance is what restricts flow, so an insulator would have a very high resistance. You can see it in the picture how resistance, the guy with the ohms on his hat, is trying to stop amp, which is current, from getting through a wire, while volt is trying to push amp through. There are several different components that you can use in a circuit. The first is a diode. A diode only allows current to move one way or the other, not both. An example of this is an LED, which will be discussed in the next slide. The next is a resistor. This is something you can use to further restrict the flow of current, not allowing it to flow from one place to another. The last is a capacitor. A capacitor stores energy in an electric field. If you look at the pictures on the left, these are the components if you saw them in a circuit. On the right, you can see what they look like in real life.
One of the components we will be using in our electronic circuit is a light-emitting diode, or LED. LEDs emit light when current flows through them. The basic LED structure is shown on the left. However, this component can be a little tricky because it only allows current to flow in one direction. Therefore, it is very important to connect your LEDs to a power source in the correct direction. Otherwise, it will not light up. An LED has two wires coming out of it, often referred to as its legs. One leg is longer than the other. This is the positive leg. This leg should be connected to the positive end of the battery, whereas the shorter, negative leg should be connected to the negative end of the battery. There are two ways that electronic components can be connected. The first is in series, shown here. In a series circuit, the current can only flow in one direction, and is the same across all components. The voltage, on the other hand, is divided up amongst the components. The second way to connect the components is in parallel. In this configuration, the current has multiple paths that it can take, and the voltage is the same across all the components. More advanced circuits will have components in both series and parallel configurations. Using our understanding of series and parallel circuits, we can calculate the currents and voltages across each component. I'll now hand it off to Claire to talk about how to make your own LED circuit.
Alright, so now that you know a little bit about circuits and how they work, today we are going to show you how to make an LED circuit with copper tape and a battery. The next few slides will have videos and descriptions of the steps to make a circuit, like the one you see here. So the first step is to find a piece of cardboard or thick piece of paper that is around 8.5 by 11 inches. After you get this paper, feel free to draw whatever you would like on it. For our LED circuit, we drew the Wisconsin W, but you can do any design you like. Next, poke holes where you would like your LEDs to go. Make sure you poke a hole for both the positive and negative legs of the LED. Next, you will draw the circuit on the back of your paper. First, draw a positive sign and a negative sign at one end of the paper. Then draw a line extending from the positive sign all the way past the holes you've poked. Then do the same thing for the negative sign. Make sure that the poked holes are in between your two lines. After your circuit is drawn with marker, you will then take 2 strips of copper tape and place them on top of the lines you just drew. These pieces of copper tape represent the wires of a circuit that you learned about earlier. After you have placed down the 2 strips of copper tape, Joe will walk you through on how to make your LED circuit light up.
The next step will be to place an LED in each of the holes so that the diodes, or the wires, are pointing towards you. You'll have to bend the wires so that both wires of each LED are touching the copper tape. For this step, make sure that the positive diode, which is the slightly longer wire, is connected to the positive copper tape, and that the negative diode, which is the shorter wire, is connected to the negative copper tape. After you have connected all of the wires to the copper tape, we'll need to secure these wires in place. In order to do this, place another piece of your copper tape on top of these wires to ensure that there is a secure connection. For this step, take out a rectangular piece of white paper and make a small fold in it. Place a strip of copper tape onto this rectangular white paper with a little bit of overhang in the wire so that you can connect it to the positive copper tape. When this happens, you'll be able to fold the paper downward and it can touch the copper tape on the negative side of the circuit and connect your circuit, allowing for the LEDs to light up. Our final step involves taking out your battery. Place the battery on the negative side of the circuit, with the negative side of the battery touching the copper tape. When you fold the white paper over so that the negative and positive sides are connected and your circuit is complete, the LEDs should light up. We have provided some links in case you would like to do this LED exercise at home. A lot of the circuit design and coloring could be found already in your house or at any of your local stores. And to create the circuit, there's just a couple pieces that you might need to buy. We have provided some of the links if you would like to check that out. This is just a slide to remind you that you can draw any shape you want and connect as many LEDs as you want to your circuit.
In this video, one of our team members has created a Wisconsin map with blue LEDs around the edges.
Thank you for coming on Wisconsin.